Yesterday, we talked about 4, maybe 5 different types of angles. What were they? A Q, which is what?
It's less than 90 degrees.
What, greater than?
0.
Good. You want to keep going? Go.
Right.
Right, which is?
90 degrees exactly.
Good.
And obtuse, which is more than 90 degrees and less than 180.
Beautiful. You got the other two? The weird ones that we talked about? Anybody?
Straight.
Straight and?
It's like 0 limits.
Yeah, 0 angle. We don't do a lot with straight angles and 0 angles. We're going to mainly focus on those 3. But occasionally they do pop up, so we talked about them, so we're good to go. This works better when you turn it on. Still doesn't work very well. I'm going to walk all the way up there. What we're going to do today is start pairing up those angles and looking at what happens when you put angles together and getting some new names. There's 5 pairs. Okay. There's the first pair. And again, I want you to remember the KISS method here. Don't overcomplicate things. What does the word adjacent mean? What does the word adjacent mean? Go ahead.
Angles that are
No. Again, you're being overcomplicated. What does the word adjacent mean? Forget about math. Next to. Good. Okay. Adjacent means next to. So there are 2 angles that are next to each other. Then you got a bunch of other stuff. They have to share a common vertex. They have to have a common side. But if you just remember that they're next to each other, you'll be fine. Not a problem. It makes no statement about their measurements. One can be bigger than the other. They can be the same size. Doesn't matter. This one's huge. Of the 5 we're going to talk about today, these are the most important because we'll do the most with them. They're called vertical angles. They are angles, as it says up there, when you intersect 2 lines or segments or rays. Question?
Can you go back?
Sure. While we're on this slide, could you write an equation involving those? Oh, hold on, let's back up even more. How many angles in that picture?
2.
3.
2.
No, there's some dissension in the ranks.
3. There's the right angle and then the 2 tiny ones.
There's angles.
How many angles in that picture again?
3.
All right, good. I knew everybody would come around there. Could you write an equation with those 3 angles just from that picture? Our son, what would it be?
PQR plus QRS equals PQS.
Close, but you said the second angle wrong.
RQS.
Good, perfect. Okay. Regardless of how big those angles are, if I take the one angle and I add it to the other angle, I'm going to get the big third angle. Well done. Okay, we good? All right. Second one, vertical angles. I take 2 things, 2 straight objects, whether it's a segment, a ray, or a line, and I intersect them. It generates 4 angles. The ones across from each other are called vertical angles. What's the relationship, forgetting about vertical angles for a second, what's the relationship between angles 1 and 2? Nope. Or what equation could you write involving angles 1 and 2? Good. And what equation could you write about 2 and 3? Same thing. 3 and 4, 4 and 1. So all of those are going to add up to 180 degrees. Okay. We'll talk more about vertical angles in a second. Let's get the other 3 in. Any questions with these? Two straight objects that intersect, the angles across from each other would be the vertical angles. Same picture, different angles now. Those angles that we just talked about that we added up and set them equal to 180 become what's called a linear pair. Linear pair. Linear means line. Pair is how many? Two. So two angles that form a line. And we already talked about the relationship between all those. 1 and 2 add up to 180. 2 and 3 add up to 180. 3 and 4 add up to 184. And 1 add up to 180. They're also adjacent. That's kind of fun. Okay, we good?
No.
Let's try an example now. We'll stop after 3. When you're solving these types of problems, the first question I would recommend you ask yourself is, what angles am I talking about? What kind of angles are those? So the two angles that I have measurements of, 16x minus 20 and 12x plus 7, are what kind of angles? Which pair have we talked about that those satisfy? Andy? They are, but why? What pair of the first 3 that we talked about? Are they adjacent, vertical, or linear? They're vertical. So you're making a statement that vertical angles are congruent. How do you know? Okay, let's back up a second. So if I go back to this slide on vertical angle, are you suggesting that an angle 2 and angle 4 are congruent? What about 1 and 3? Is that always true? Is she right? Do you believe that angle 2 and angle 4 are congruent? Why? Just because they look congruent?
Because they're the same angle on the 8 and the 80
What do you mean?
Like, angle 2 is the same as angle 4, it's just a flip it.
But how do you know that though? That's what I'm asking.
It's on the line, on the 180 degree line. It's either equal to 2.
Are you convinced? Okay, so what do we know about, we talked about this already, but we'll do it again. Angle 1 plus angle 2 equals what? 180. Angle 1 plus angle 4 equals 180. They both equal the same thing, so therefore angle 1 plus angle 2 equals angle 1 plus angle 4. Is that legitimate math? Right? Okay. Subtract angle 1 from both sides, and sure enough, I have angle 2 being equal to angle 4. And notice that little explanation / proof I just did doesn't depend on the measurements of the angles. It just depends on the setup that we have. I could do the same thing with 1 and 3. But basically, what I just did is proved exactly what Andy said, in that they are in fact congruent. Okay, so if I come back to this problem, if what you're saying is true and those angles are congruent, what should I do with the two expressions?
Set them equal to.
Do it. Solve for x. That's the first step in the problem. Solve for x. And then okay, you want me to go with you? Okay, just go to that first door on the left. And just say, yeah, and just ask if you can use their pencil sharpener. Nice new room, but they won't give me a clock or a pencil sharpener. I guess they can't be trusted with it. You might hurt somebody. Okay, got x? Okay. How do you find angle CAT then? There's no values for CAT in there. Yeah.
You find the value of angle of the other angle on the 180 degree line, and then subtract that from the 180.
All right, let's back up. Al, what'd you get for x?
180
4x equals 27.
Anybody else? 27? Okay. So then plug it back in and you find that those angles are whatever, 27. Wait, x is 27?
4x.
Oh, 4x is 27, so what would x be? 27 over 4, right. Are we in agreement on that?
Yeah.
Okay, good. So then plug it back in and solve for those angle measures. Hopefully they turn out to be the same thing. And then what are you saying you would do to find CAT, Hannah?
You would take 180 and subtract it from whatever you got from that.
Beautiful. Do you have an answer, by the way? Anybody? Answers? Yeah, one thing you gotta get used to is we're pretty much done with nice, pretty answers. So some of you solving problems, if you get an answer that's not something pretty like 2 or 3 or -1, you think you made a mistake. It is not unusual from this point on to get weird answers like fraction answers, like 27/4 is okay. We'll talk a little bit more in the future. I'll make sure that you know how to use the fraction element on your calculator. Got an answer, Augie?
77.
77, can somebody back that up? Yes? No? What are you saying is 77, the final answer for CAT or the value for the angle?
For CAT.
For CAT. You got the same thing?
Yeah, I got 80 for the first one, 74. No, I got 89.
88 equals 88.
Hold on. Do we all agree that x is 27/4?
Oh, yeah.
Okay. So then, if you plug 27/4 into this, what do you get?
88.
88. So therefore, how big is CAT? 92. Okay, so look at that problem for a second and tell me what's wrong. By the way, those numbers are correct.
Isn't it good?
What's wrong with that?
It's bigger.
Go ahead.
They should all be equal, like, they should all have the same angle.
They don't have to. Yeah.
16x minus 20,
Mhm.
12x plus 7.
And I think they are. If you plug 27/4 down at the bottom, you get 88 also. What else? Yeah?
And smaller sections, like it's more, I believe, like, I don't know how to explain it, like 92, it's a acute angle, and 88's an obtuse angle, but they're like, the measurements don't line up to the angle.
Correct. Based on my picture, angle CAT should be an acute angle, but I got a value of 92. This angle up on top should be an obtuse angle, but I got a value of 88. Which one do you trust, the picture or the numbers? Always trust the numbers, yes. So don't assume that that's going to be acute or that's going to be obtuse when you solve the problem. Okay, fourth type, supplementary angles. Two angles whose value add up to 180 degrees. That's it. Tommy, give me an example of two supplementary angles.
90 and 90.
90 and 90 are supplementary angles. Very good. Give me another one. Get a little crazy here.
1 and 170.
Ooh, you are a madman. 1 and 179. Very good. Let's suppose one of the angles is x, Tommy. How big would its other angle be?
180. Well,
All right, hold on, let's try this. Suppose I tell you one angle is 5 degrees. How big is it? What's called its supplement, the angle that you add to it to get 180. So suppose one is 5, how big is the other one? Where'd you get 175?
180 minus 5.
5, Okay, so suppose I tell you it's 10. Okay, so you're seeing a pattern here, right? So suppose I tell you it's x.
180 minus x.
Perfect. Okay. That comes up a lot. If you have an angle, to find its supplement, you subtract from 180. If you don't know how big the angle is, you still subtract from 180. So he didn't know what the angle is, we just called it x. Therefore, it would be 180 minus x. Last pair, complementary angles. Two angles that add up to 90 degrees. 30 and 60, 45 and 45, 1 and 89. X and 90 minus x. That last statement is pretty important. Adjacent angles are very specific as to where they're located. A linear pair is very specific, a vertical angle is very specific. These are not at all. You could have angles on opposite sides of the globe. If one angle is 2 degrees and the other one is 88, then they're complementary. Okay. We're running out of time, so I'm not going to go through these specifically, but let's talk about how you would solve it. I have two angles there. What kind of angles? Well, there's three actually, but let's talk about the two regular angles. What kind of angles are those?
Supplementary.
They're supplementary. What else are they? They're adjacent. What else are they? Nope. They are also a linear pair. What would I do with those two measurements there? What would I do with the 10x minus 5 and the 4x plus 3? Good. Add them together, set them equal to 180. In this problem, what kind of angles are those? Complementary, is that what you said? Complementary. They're adjacent. What would I do with those two angle measures? 2x plus 2 and x plus 1. Beautiful. Add them together, equal 90. Okay, we're going to start with this tomorrow, so you'll see at least one of these on the homework tonight. It might give you a little bit of difficulty, but you should be able to do it based on the discussion I had with Tommy. Day 8, yes. The ocho. Sit down.